All right, let's talk about time. We all feel it, right? The clock on the wall, the calendar on our phone, it just seems to tick by second. It feels totally simple, totally fundamental. But what if I told you that our whole gut feeling about how time works is completely wrong? Yeah, according to physics today, the idea of time as a simple straight line is an illusion, and we're going to tear that illusion down. So, you just heard from the physicist Carlo Rovelli. Most of us, we picture time just like he said, as one long, straight line. It starts way back at the Big Bang, and we're all just riding along on this single moment called now into the future. But that whole picture, it's just not how reality works. Not even close. So, in this explainer, we're going to see why. But hey, before we can break time, we've got to understand the version we all think we know, the one that humans have spent literally thousands of years trying to perfect, all in the search for a single, reliable tick-tock for everyone. I mean, just look at our history. It's basically a story of us being obsessed with precision. We started with sundials and water clocks, just trying to get a handle on the day. Then came mechanical clocks that could finally track seconds. The pendulum clock, that was a huge leap forward. But the real game changer was the atomic clock. No gears, no pendulums. It uses the vibration of atoms themselves. And now, today's optical clocks are so ridiculously precise, they won't lose a second over millions of years. And this whole history of building better and better clocks that all agree with each other, it baked this idea into our heads, this picture of time as a single, giant river flowing everywhere at once. It's the same time in New York as it is in Paris, right? It just flows from a past that's already happened through this one single now that we all share and into some unknown future. It feels so simple, so obvious. And it turns out it's profoundly wrong. Okay, so we've built up this nice, simple, common sense idea of time. Now let's break it. This is where a guy named Albert Einstein strolls onto the scene and starts pulling on a few threads, and the whole thing just unravels. Think about it. The entire point of a clock is that it ticks in sync with every other clock. If you have two perfect clocks and you bring them back together after a journey, they should read the same time. If they don't, one of them must be broken, right? Well, Einstein asked a truly wild question. What if neither clock is broken? What if time itself is actually passing at different speeds in different places? And this leads to one of the most mind-bending discoveries ever. Gravity actually slows down time. The stronger the gravity, the slower time ticks. So a clock down at sea level runs just a tiny bit slower than a clock on top of a mountain. The difference is incredibly small, but our modern clocks can actually measure it. And get this, it means your head, which is just a little farther from the Earth's center of gravity than your feet, is aging just a little bit faster. Your own body isn't even in the same time zone. Wild, right? Okay, hold on, because it gets even weirder. If the rate of time isn't universal, what about the moment of time? That idea of a single now that we all share across the whole universe? Yeah, physics kind of destroys that too. The idea of a universal now is actually meaningless. See, the speed of light isn't just a cosmic speed limit, it's the speed of information. When you look at the sun, you're not seeing it now, you're seeing it as it was 8 minutes ago. When astronomers look at our neighboring galaxy Andromeda, they're seeing it as it was 2.5 million years ago. So there's just no way to say what's happening now on Andromeda. Your now is just your own little local bubble. Okay, so time isn't universal, and now is just a local thing. But come on, at least time flows in one direction, right? From past to future, the famous arrow of time. That has to be real. Well, let's take a closer look. I know, this sounds like a silly question, but it's actually one of the deepest puzzles in all of physics. Almost all the fundamental laws of nature, from Newton to Einstein to quantum mechanics, they don't care which way time goes. They work perfectly fine forwards or backwards. If you filmed a planet orbiting a star and ran the movie in reverse, it would look totally normal. So why is our experience so one-sided? Why do we have memories of the past but none of the future? The one big clue we have comes from a law called the second law of thermodynamics. It says that something called entropy, which is just a fancy word for disorder or randomness, always increases. Think about it. An egg is an ordered, low entropy thing. Scramble it, and it becomes a disordered, high entropy mess. And you will never, ever see a scrambled egg just unscramble itself back into a perfect egg. This arrow of growing disorder seems to be where time's arrow comes from. A physicist named Ludwig Boltzmann figured out why. Imagine a box of balls, perfectly separated, red on one side, green on the other. That's a very specific
ordered state. Now shake it. They're going to mix up, right? Why? It's not because of some deep, mysterious force of chaos. It's just probability. There are way, way, way more ways for the balls to be mixed up than for them to be perfectly separated. Disorder is just statistically more likely than order. But here comes the final incredible twist. What even is order? Ravelli points out that it totally depends on how you look at the world. For someone who's colorblind, those separated red and green balls wouldn't look ordered at all. And that means that entropy and the arrow of time itself might not be a fundamental feature of the universe. It might just pop into existence because of our own particular blurry way of looking at things. So let's recap. Physics seems to be telling us there's no universal clock, no universal now, and no fundamental arrow of time. The universe, at its deepest level, looks timeless. So how in the world do we get from that bizarre reality back to our everyday experience of a flowing river of time? Well, our everyday experience is basically built up in layers of approximation. We're too big to see the quantum weirdness. We live in a pretty weak gravitational field, so time feels like it's the same everywhere. And we see the past as ordered because of our special point of view. But that last piece, that feeling of time actually flowing, that's not out there in the world at all. It's in here. It's in our heads. You know this feeling. Psychologists call it subjective time. We've all felt it. A boring meeting feels like it drags on for an eternity, but a fantastic weekend with friends just vanishes in a blink. Time that's packed with new and exciting stuff seems to fly by. Our internal clock isn't steady at all. It's elastic, and it's constantly being stretched and squeezed by our emotions and what we're paying attention to. And this gets to the absolute heart of it all. Your brain doesn't just passively watch time go by. It actively builds your experience of time. Some neuroscientists say our brain is basically a time machine. Its fundamental job is to use memories of what has already happened to constantly predict what's about to happen next. And it's this process, this constant dance between memory and anticipation, that creates our sense of a journey through time. So let's put it all together. That feeling we all have of time flowing like a river, carrying us from past to future, that isn't a feature of the universe. The universe is just a collection of events. The flow is the story our brain tells itself by stitching those events together. The past is what our brain remembers. The future is what our brain anticipates. The passage of time is the narrative our mind creates. And that leaves us with one last, pretty mind-blowing question to chew on. If that rich, emotional, flowing river of time we all feel is really just a story our brain is telling itself, a story built from memory, perception, and emotion, does that mean we have the power to change that story? Can we actually alter our own experience of time? Now that is something to think about. Thanks for joining me for this one.